Hey guys, this is going to be a little bit of a side quest, getting back into creating videos, and I came across this article that was suggested by a friend of mine for me to read. One of the things that I like to do when I'm reading along is I like to, when it's available, the sound for voice. Sometimes it's nice to have somebody read along with me while I'm actually reading. And one of the things that I noticed while I was reading this article was that this recording, this WAV file, actually goes silent. Here, I'll
To
list.
1 gigabyte. Together, these dramatically reduce memory requirements while preserving the capabilities and quality you expect from Gemma 4.
So at about a minute 40, I put the player ahead just a couple of seconds, but at a minute 40, the sound dies off and there is no more uh, um, voice speaking. I figured out that it was actually two different voices that you can choose from. And if we choose this
While
other
PTQ
voice,
is already a
you can see that it's different in length. The not great file is 10 minutes long, and the good file is 5 minutes long. But also that this voice
format to maximize performance for
continues on past the minute and 40. So what I did was I opened up development tools and I found the little data object that was actually part of the player, and it gives us two links to two different files. So I grabbed these off of Google's API, and you can see here that the WAV file that we're troubleshooting is quite flat. So you see all of this activity at the beginning of the file, and then you see just a straight line. Compare that with a more healthy or a full file. You can see here all of this activity, and it fills up this entire center area. So what we're going to try to do is I created a simple little script that basically could read through the file and see whether or not this waveform goes flat, and if it does, give us a little bit of an alert. And like I said, this is just a straight, fast little thing. This only took me around 10 or 15 minutes. So I just want to give you that warning because we're about to see some vanilla JavaScript, some unfactored vanilla JavaScript. Okay, so I'll hit the clear on this, and you can see that it's just a simple little output. It gives us a little bit of information about the file itself, and then I actually I'm feeding it the two different files that we have. So we'll start at the end of the script here. We've got the good one and the bad one. We're feeding it the bad one and the good one here in the script. And you can see the output, silence detected, audio went flat at a minute 40, and then scan complete, file structure looks healthy until the end. Fairly simple code. Like I said, this is not production ready by any means. The functions kind of sort of do a little bit too much, and also it's plain JavaScript, not TypeScript. And I don't know if anybody even puts plain vanilla JavaScript in production anymore. But we're setting a couple of variables in our function. We're giving the file path, and then we're opening up the file, and we're setting a couple of defaults. We're also setting our silence threshold. So as the little note here says, lower is stricter silence. So we're looking for a silence of about 5 seconds. One of the improvements that I made with Gemini while the two of us were working on this script was the first script that it gave me. It relied on npm packages that it wanted me to download and use. And in this file, we're just going to open up the file and we're going to chunk through it in little tiny chunks. And then we're going to load that little tiny chunk into memory. And we're not necessarily going to have the entire file loaded into memory at the exact time. So, and we're using the native node objects to do this because you can see here, the only thing that we're requiring outside of, what comes naturally is the file structure. package. So what we're doing is we're grabbing tiny little bits. We've got to skip over the header first, and then we're grabbing the bits in sections. And this is where the script gets more interesting. We're going to loop through the script, and we're going to use a mathematical concept called RMS, or root mode squared. Yes, root mode squared. Let's just double check that. Root mean squared. Root mean squared. And the root mean square is a mathematical formula that allows us to measure the upswing and also measure the downswing on this line, and not necessarily see a line that is perfectly symmetrical as being blank. So a little bit of a flyby on that, but I'm going to do some more videos on wave files and graphs and things like this. Graphs is not the right word, but trust me, this is going to get better. Okay, so that's really what we're doing, is we're using the mean of the values of this wave file, and then we're using the square root of that, so that the offsets basically don't make it look like there's nothing happening in the file. So then if our root mean square is less than our silence threshold, so we're only looping through at a little bit of the file at a time. So as soon as we hit our silence threshold, we're exiting out. And like I said, this is not production code by any means. You can see here that we have like these kind of sort of nasty-ish embedded if statements here, but you can see here, if silence duration is less than or equal to required silence, then we are giving our alert, silence detected, audio went flat, and then we're giving the user the time. So once again, we'll run this script. We'll just run this script real quick. Not that anything has changed, but yeah, it was a fun little journey to take. Like I said, this code is not production ready, but it only took me 10 or 15 minutes to create something like this. And so to go from, found a problem to have somewhat of a workable solution, and a fairly good workable solution in a very short time. So thank you guys, and I'm looking forward to creating more stuff.